Welcome to this video on understanding probability distributions in data mining. Today, we'll explore key concepts and examples to help you master this fundamental topic. First, let's take a look at the outline. We'll begin by defining random variables and understanding their types. Then, we'll explore how these variables connect to probability distributions. Next, we'll examine the characteristics of specific distributions, including Bernoulli, binomial, normal, and t-distributions. Finally, we'll show how Python can be used to visualize and calculate probabilities. A random variable is a way of assigning numerical values to the outcomes of a random process. These variables can either be discrete, taking countable values like the number of loans a client has, or continuous, taking values within an interval such as body mass index. Probability distributions then describe the likelihood of these values. Next, we have a code example that visualizes a discrete random variable using a bar chart. The code demonstrates how to assign probabilities to specific values and display the result graphically. The Bernoulli distribution describes random variables with two possible outcomes: success or failure. It is parameterized by p, the probability of success. For instance, we can use it to model whether a loan client defaults or not. In the code snippet, we calculate the probabilities for both outcomes using Python's scipy library. The binomial distribution builds on Bernoulli trials by describing the number of successes in n independent trials. For example, it can model the number of left-handed individuals in a group of 25 students. In the corresponding Python example, the code calculates the probability of observing exactly two successes. Next, the normal distribution, also known as the bell curve, is characterized by its mean and standard deviation. It is widely used to model real-world data like body temperatures. The code demonstrates how to plot the probability density function for a standard normal distribution using Python. The t-distribution is similar to the normal distribution but has heavier tails, making it useful in hypothesis testing when sample sizes are small. It is characterized by degrees of freedom, which determine the shape of the distribution. Lower degrees of freedom result in heavier tails. In the code example, we generate and visualize a t-distribution using Python. To summarize, probability distributions are essential tools for modeling the likelihood of outcomes for random variables. Named distributions like Bernoulli, binomial, normal, and t-distributions provide specific frameworks for analyzing data. Python is an invaluable tool for calculating and visualizing these distributions in practice. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.